So good morning, everyone. Welcome back to Math 115. So today we're going to talk a little bit more about the inverse trig functions, which we all know and love. And we'll have a bit of partner practice for that. And then we're going to have the quiz. So the quiz is over sections 4.1 to 4.4. No calculators allowed, as usual. You know the drill by now. So I mentioned that there was an outage with Pearson last night, so I extended the 4.4 homework to be due also on Thursday, because some people were working up down to the wire and weren't able to finish. So I'm extending that homework to be due on Thursday, same day that the 4.5 homework is due. Regarding Pearson, I noticed something really strange yesterday when I was looking at your homework grades, which is that if there was an assignment that you did not start, it was not factoring that into your homework average or something like that, something strange. Like it was not assigning you a grade of 0 unless you had opened the homework assignment. So obviously that's incorrect. If you just didn't do a homework assignment, you need to get a 0 for that homework assignment. So I put in the grades for the zeros, and probably some of you are going to notice your homework percentage dropped. That's because it was artificially inflated. I don't know why Pearson would do that. It doesn't seem to make much sense to me, but it's been corrected now. So if there's a problem with your homework grade and you think it's not right, then calculate it for me and send it over and say, hey, this isn't right because actually I did this thing, or actually I shouldn't have got this grade on this thing, or whatever, and I'll take a deeper look. But what I did was I just kind of told Pearson on like a batch basis to just look, if someone didn't do a homework assignment, yes, they need to have a 0 for that homework assignment. So take a look at your homework grades and make sure that they're adding up in the way that you think they should. And if they aren't, then send me an email. So one thing I want to mention is I also updated the homework grades in Blackboard to reflect your homework average on Pearson. This does not include the 2 dropped homework assignments, okay? It's too much work for me to try to figure all the drops as we go along, because I'd have to recalculate it every single time that you had a homework assignment. So I'm not going to do that. Instead, I'm just going to tell you that you can figure it out on your own. Like, what would your grade be if I got rid of these 2 zeros, or if I got rid of this one I only got a 50 on, or whatever, okay? Deal? Any questions on the online homework, like Pearson, stuff like that? Yeah.
So I have more trouble with like putting the graphs. So like for 4.4, a lot of you guys like move it horizontally a little bit, like ever so slightly. I had trouble like actually doing that, to be honest.
Does everyone else feel the same?
So like on like the graphs for 4.4, you can't like move it over slightly for like some of the questions. I just don't know how it works. It just
I think
for the
amplitudes,
I like copied and pasted pi. And then like
Yeah, that's what I had to do.
I didn't think about that.
Yeah, if you type out PI, it turns into pi. By the way. I wrote the directions to figure that out. I was like,
When you do the graph, there's no like you can't insert a pi. You just hit that one and you're done.
type PI.
You have to
It's like
type.
the little box.
Oh, actually.
Yeah, seriously.
No, I had a problem with that too.
No, I read the directions to figure that out.
That's what I did.
Don't worry, I freaked out too. I was like,
Yeah, that's something that you learn just like after interacting with computers in a mathematical capacity after a while. Typing PI, that's always for pi.
Did not know that. Okay.
But yeah, you can't be blamed for not knowing that. So just send me an email with like the problems. I'll go take a look, and it's on the 4.4 homework, right? Okay, so you should still be able to.
Oh yeah, I can do it now.
You should still be able to go back and look at that, hopefully. Any other problems with the Pearson, other than sometimes it's annoying?
Sometimes it's
Okay. Oh yeah, I remember the troubles that I had when I used to do online homework or whatever. I miss those days compared to what I do now. But anyways, all right, so let's get back on track. So that was the homework. your next assessment is today. That's quiz 6, 4.1 to 4.4. We'll do that in the last 15 minutes of class. I better set an alarm so that I remember. That'll be I'll set the alarm for 9:03, so I have time to pass them out. All right. Other than that, my office hours tomorrow are going to be from 2:30 to 4 p.m. I'm going to keep doing them in the Learning Center. It's been working for me in the Learning Center. So if you want to come by and do some of your 4.5 homework or your 4.4 homework that you didn't do last night, either because you forgot or because Pearson shut you out, then come to office hours in the Learning Center, and I'll be in cont 102. We got the hexagonal tables. It'll be a grand old time. I'll bring the candy. All right. Any administrative questions before we start in on content for today? Okay, it doesn't seem like there are any questions, so let's review what we talked about last time. So, feels like a lifetime ago. We were in class on Monday. We were learning about inverse problems and why they're so tricky. The reason inverse problems are so tricky is usually when we go in the forward direction, there's like a very clear answer to the question. But oftentimes when we go in the reverse direction, we say, I'm going to give you the answer to the question, and you tell me what the question was. That's a trickier direction to go in, because that answer could be the answer to many different questions, right? So I need to be very careful in how I phrase this kind of reverse logic so that I can ensure that I'm asking a good question. A good question is a question that only has one answer, okay? That's a good question, mathematically speaking. So how did that factor in for inverse trig? Well, we said we wanted to understand what is the angle alpha such that sine of alpha is equal to 0. And we noticed something. Look, sine of alpha is going to tell us the height of a point on the unit circle. No matter what height I choose, okay, no matter what height I choose, there's always going to be 2 points on the unit circle who have that height, right? And of course, each of these points has a corresponding angle which points at those points. So this would be one, and then this would be another one. And so if you ask the question, well, what angle is going to produce a point on the unit circle whose height is this height? You would rightfully come back to me and say, your question sucks. There's 2 of them. What do you mean the angle, right? Because if I say like the angle, it implies there's a major implication that there's only one, right? But here there are 2. So what do? We just throw one of them away. We just say, I'm not talking about that one over there on the left. I only want the angle which produces a point who has this height, and the angle should be between negative pi over 2 and pi over 2. And then we can get a unique answer, because if you look at the collection of all of the points on the right half of the unit circle, they all have a different height. All of these points on this right half of the unit circle have a different height. Okay? And also we achieve every height possible, right? For all the way from -1, that's the lowest height possible on the unit circle, up to +1. So what are we going to do when we're doing inverse cosine? Well, we want to ask ourselves, what is the angle which is going to produce a certain x value, right? What is the angle which is going to produce a point with a certain x value? And you can clearly see there's going to be 2. There's going to be one on the top part of the unit circle and one on the bottom part. So for inverse cosine, I say, well, I only want the angle which is going to produce a point with a certain x value, and that point should live on the top half of the unit circle. Because what is true about all of the points on the top half of the unit circle? They all have different x values. And every x value possible is achieved. So this is why when we're asking inverse cosine, we're going to restrict our search to a certain region. Okay, we're going to restrict our search to a certain region. Same thing for inverse sine, it's just we need a different region. Is it clear why the regions should be different for sine and cosine? Yeah, because it has to do with whether we're searching for the x value of a point or whether we're searching for the y value of a point. Okay, so that's a bit of a difference there. So like I said, I mean, look, inverse problems are not just hard because of these problems, but they're also hard because typically you need a great understanding of the forwards problem in order to say, I'm going to then do the reverse problem, right? It's like if you wanted to learn how to play, well, actually, I don't know if it would help you that much. I was going to say if you wanted to learn how to play like a piano piece backwards or something, then you would want to know how to do it forwards, but that probably wouldn't help you, would it?
Just get it out with it backwards. Like it wouldn't help if you got backwards either.
Yeah, I don't know. Anyways, bad analogy, but for math, it's useful to know how to go in the forwards direction. That will inform you of how to go in the backwards direction. Okay, so that's why I think this is so hard for many students when they get to inverse trig if they don't have a good enough understanding of regular trigonometry. They find inverse trig to be, what is the word? Not, oh, there's just like the perfect word here. But it's not intangible. What is it? Oh well. Anyways, they just find it to be difficult. All right, so we did some practice last time. We saw why this problem is sort of ill-posed from a graphical perspective. Namely, if you want to ask what input is going to give us a certain height as an output, well, there's going to be multiple inputs which are going to give you a given height. In fact, there's going to be infinitely many because this graph repeats over and over again. So we need to restrict our search to a subsection of the graph on which none of the y values repeat. For sine, that means we go from negative pi over 2 up to pi over 2. For cosine, that means we go from 0 up to pi. Okay, 0 up to pi will give us all of this subsection of the graph, not repeating any y values. Okay? So let's see how we do it. So, yes, of course, well, let's see the definitions first, and then we'll see how we do them. So, the way I write it is sine inverse of x. Okay, I do this little -1 here, and I want to remind everyone this little -1, unlike when I write sine squared of x, when I write sine squared of x, I mean you take sine of x and then square it, right? That's what I mean. Not so when I write this -1 here. I'm not talking about a -1 power. I'm talking about the inverse function, which is completely different. So another way you could write it would be to write arcsine. Then you'll never be confused. But you have to write more letters, so there's a huge trade-off there. So we say sine inverse of x is going to be the angle theta, the angle alpha, such that sine of alpha is equal to that output, okay? And I don't want anyone to be confused here because I put x in here, right? What I'm looking for is the point on the unit circle whose y value is x. And I want to find the angle which points at a point whose y value is whatever the input of this function is. So we use x all the time as a dummy variable, a placeholder for a number. But that number in the context of the geometry is actually going to represent a y value. Okay, so it's a little bit confusing because you think, well, x, shouldn't that be an x value? X doesn't necessarily, whoa, what happened? X doesn't necessarily always mean something in terms of geometry, right? We can use any letter we want. I could do sine inverse of t. I could do sine inverse of k. I could do sine inverse of any letter I want. It's just that whatever that number is needs to go in the y value of the point I'm searching for. Okay, so, and we have this additional requirement that alpha needs to be between negative pi over 2 and pi over 2, inclusive. For cosine, alpha should be between 0 and pi, and for tangent, alpha should be between negative pi over 2 and pi over 2 exclusive? We exclude pi over 2 because alpha cannot be pi over 2. Why? Because if it was, it would be plugged into the tangent function, and tangent of pi over 2 is undefined. Okay, so the alpha can never be pi over 2 because we cannot plug that into the tangent function. Okay, so let's review really quickly this example here. So we wanted to do this one, sine inverse of negative square root 2 over 2. So what did we do? We want to find the angle alpha such that sine of alpha is negative root 2 over 2, and the angle is between negative pi over 2 and pi over 2. So first of all, we recognize that if sine of alpha is negative square root 2 over 2, then we are searching for a point on the unit circle, which is on the right half of the unit circle, whose height is negative square root 2 over 2. Okay, so I just forget all about the left half of the unit circle when I'm doing sine inverse. When I'm doing cosine inverse, I'm going to forget all about the bottom half of the unit circle. But for sine inverse, I just am going to forget about this side, and I'm going to look for a point whose height is negative square root 2 over 2. So that would be this point here. And if the height of this point is negative square root 2 over 2, then the length of this line segment is square root 2 over 2. So we also know that this length is 1. Yes, we also know that this length is 1. So I know that 1 minus 2 over 4 is going to be equal to x squared. Okay, Pythagorean theorem. So if you do 1 minus 1/2, that's a half. Take the square root, you get 1 over the square root of 2, which is again square root 2 over 2. Okay, so this 45, 45, 90 triangle is basically what we determined. But you don't even need that. You can just use the Pythagorean theorem, which will tell you what the length of the other side is. But once we know that these two side lengths are the same, and this one is equal to the length of the other two times the square root of 2, then we can recognize that this must be a 45, 45, 90 triangle. This is a 90-degree angle, and the other ones are 45, which means that, okay, the angle alpha, which produces this value when you plug it in to the sine function, should be the angle negative 45 degrees. Okay, negative 45 degrees. Except we always express angles in radian measure when we're doing inverse trig. Okay, we always express in radian measure. Okay, so negative pi over 4, that's the angle which we need to put in here in order to achieve a point on the right half of the unit circle whose height is negative square root 2 over 2. Any questions on that example? Mm-hmm.
So where did you get the negative pi over 4?
So I know that this angle, okay, so I found where the point was, and then I made this triangle, and I was able to solve for the side lengths of the triangle. Are you okay with that part? So since I know that the side lengths of this triangle obey the proportionalities which are seen in a 45, 45, 90 triangle, I can then infer that this angle and this angle must be 45-degree angles, right? So then I know that the angle, which is going to point in this direction, is going to be negative 45 degrees, right? You agree with that? And then how would I go from that? To go to radians, I would take negative 45 degrees, and what would I do to it? Multiply by pi over 180. When I do that, 45 goes into 180 4 times, so this would become a 1, and this would become a 4, and I'd be left with negative pi over 4. Make sense? So yes, good question. I just converted in my head because once you do trigonometry for a long time, you recognize certain angles for what they are. The ones that are worth memorizing, 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, 90 degrees is pi over 2, 180 degrees is pi, 270 degrees is 3 pi over 2, and 360 degrees is 2 pi. Those are the ones that are worth memorizing. Okay, so I just memorize like a handful in this quadrant, and then I memorize the ones that go straight up, straight left, straight down, and straight right. Why? Because if I want to get the angle which is in the third quadrant, which looks like this, what am I going to do? I'm just going to take pi, which goes halfway around, and I'm going to add to that an additional 45 degrees. So this would be 5 pi over 4, because I just take 4 pi over 4 and add pi over 4 to it. Does that make sense? So this is something that it takes some time to kind of get used to visualizing things in terms of radians, okay? Any other questions on this? Okay, then we're going to do some partner practice now. We're going to do some partner practice. So our goal here is to just, oh, I shouldn't do square root 2 over 2. Why don't I do 1/2? Yeah, this looks good. Okay, so we're going to work with our partners to find the angles out of these processes. So let me make it as big as possible so you can all see. So I'll be walking around to help you. If you need some help, just raise your hand. And we'll work on this for maybe 8 minutes.
No, it's confusing because like pi over 6 is 30 degrees, the square root of 3 over 2 all the way to 2. So that, I think it would be that way. Oh, it just came. That would also be. Okay, I'm doing it. I think it's fast.
Negative pi over 2 and pi over 2. So what kind of angles are those? Those are angles that point
The top.
either down in this quadrant or up into this quadrant. What kind of angle would need to be producing something like this? It'd have to be something like 3 pi over 4. It'd be too big. So this is not the point that we want. We want this point. We want the angle which is going to point at this point, and we know something else about this point. Namely, the y coordinate is a half. Put that in there.
So I'm pretty sure you could just like reflect it and then say, well, that's the issue. So we could just do x squared.
Yeah, exactly. So this is 1. So we do x squared. So now what are we going to do here? We know this length is 1. We know this length is 1. And we can use the Pythagorean theorem to find out what the x coordinate is. And then what we're going to try to do, we're going to try to figure out what kind of triangle is this, so that we can figure out what kind of angle that is.
Square root 2 over 2 is square root 2 over 2. Yeah. Oh, what's it on this
Well, let's solve for
one? I
that.
think it's 7 pi. Yeah.
So that's 1/4. In fact, over the other side, we get 3/4. So x squared equals 3/4. Take the square root of both sides. We get x is equal to the square root of 3 over 2. Okay, so that's the x coordinate, square root of 3 over 2. So this length is like the square root of 3 over 2. This length is 1/2, and this length is 1. So these two sides, this one is twice as much as that one. The kind of triangle that has one side length which is twice as long as the other is the 30, 60, 90 triangle. Where this one would be x, this one would be x, 2x. Can I do the 2x? Yeah. This would be 2x, this would be x, this is 30, and this is the 90. So that informs us of what kind of triangle it is. And the shortest leg is going to be across from the smallest angle in the 30, 60, 90. Which means that this angle here is going to be 1. Yeah, so 30, right? So this angle has to be 30 degrees, right? Which is what we're looking for, right? We want the angle which produces a point whose height is 1/2. Yet that angle we have surmised now is the angle 30 degrees. But of course, we want to give our answer in terms of radians. So what would it be? Okay, you haven't done it yet, but how do I convert? I'm going to do in backwards, okay, whatever. 30 degrees. You already learned that. What would I multiply by in order to convert to radians? No.
You were?
Multiply by 5 over
Yes. One more stage.
so similar process.
Now we can.
No, our So this is pretty good, right? We got a height of 1/2.
Because it's negative.
And the x coordinate is square root 3 over 2. So what kind of angle is that? It's the 30-degree angle, right? So the answer is just going to be 5 or 6.
Okay, well, you know,
That's a 30 degree.
you already continued.
Yeah, 18, yeah. So, this gets well back, I thought you did. But, wait, then you by 36, so it's just 5%.
Really?
That's the answer.
I guess. Yeah, you're in good.
No, no.
It's not just.
I don't know.
Wait, no.
Oh, okay.
This way.
This one. The.
So don't you want to find
Good.
this one?
What do you get for this one?
I just didn't write it down. She got caught up in talking on the house.
Sorry. I was like scared because like last time I did the quiz, I was like so drained. So I drained for this one. Someone told me it would help. To where? Yes. Really? That's what they say. Oh, goodness. I do love, I love it. Yes, sometimes. Thank you.
As you grow.
Yeah. I'm not gonna apologize.
I know. It's okay. Yeah. You don't have to.
Well, more than something to give us.
I think I just need gives too much.
This case, there is.
Today they didn't have any food. So I ate my eight course food,
No,
which is like
you know,
the food.
We're doing post, so this is not gonna be the y value of a point. It's gonna be the x value. I'm looking for a point whose x value is negative square root of 2. We're gonna draw a
How many
triangle
cats?
and we know this thing here is square root of 2. Okay, let's get into this. We'll talk more about that after class if you want. All right, we're gonna have to talk these over next time in class. So we're gonna do the quiz now. So please put everything away except for a pencil. If you have an Apple Watch or a smart device anywhere else on your body or your cell phone, please put it all the way into your book bag and zip it up. So please leave these face down on your desk until everyone has one, so it's fair.
No, let go.
How are you? How are you?
Every 45.
Yeah, if we need 4 hours, 7, that's fine.
I don't know if it's switching.
I hate this.
Everyone have one?
Is there a name? Why should I put my name on it? I do it on the SAT.
Okay, does everyone have a quiz now? Okay, you may begin.